Okay, good afternoon, everyone. Welcome to this my YouTube channel. My name is Gbaraga Baradum, and I'm very happy to have you here today. And please, if you are new here or you have not subscribed to the YouTube channel, I beg of you, kindly subscribe to the channel so that we can get access to each other and study together and get the best out of our study. Actually, to subscribe, they're not going to charge you any money. It's just a means of getting access to information concerning where you subscribe to. So thank you very much. Now let's look at what is before us today. Today we are looking at homogeneous function in differential equation. We are looking at homogeneous function in differential equation. What do you understand by homogeneous function? Homogeneous function in differential equation is a homogeneous function that satisfies the following properties. It's a homogeneous function that satisfies the following property. And the property we're talking about the homogeneous function. A function of a two variable, let me just say f, that is f simply mean was function. A function of x and y is homogeneous of degree n if a function f lambda x comma lambda y equals to lambda raised to the power of n, which simply mean the degree, that n simply mean the degree of that function, of the function x comma y. I will explain that more in the example below. So let's look at the example 1 of how to solve homogeneous function. Let's look at example 1 of how to solve homogeneous function. We have f x comma y. This f simply mean what? The function of x and y is equals to 4x square plus 6xy plus 8y square. So how are you going to find the homogeneous function? For us to find this homogeneous function given below, f x y equals to 4x square plus 6xy plus 8y square, we must replace, anywhere we see x, we replace it as lambda x. And anywhere we see y, we replace it at what? Lambda y. This is how to solve this homogeneous function. So let's look at how to solve it. You know that the function they give us was function x and y. So in this way we have x here. So we substitute lambda x instead of x. That's why you have this lambda x, comma. Here we substitute lambda y instead of what? Y. Then equals to, here we have 4x squared. Instead of this x now, we substitute it and have what? Lambda x square, because there is the power of square here is on top of this x. That's why we have this square here. Then plus 6, this 6 now, and we have x here. Instead of this x, we substitute and put what? Lambda x times this y. This y now, instead of y, we put what? Lambda y, because we are substituting x in place of lambda x in place of x, and lambda y in place of y. Then plus this 8 now. Instead of this y, we substitute and put what? Lambda y, and it have a power square. That is why we have square on this particular terms. So in this case now, let's look at how to move. So you know that this square now, we have 4 now. This square here on top of this lambda and lambda x will multiply the everything that is in the bracket. So that's why I have square of this lambda become lambda square. Square of this x we have x square. Then plus this 6 now. Here we know that lambda times lambda give us lambda square, and x times y, we have xy. Then plus the 8 here, you have lambda y raised to the power of square. This square is going to multiply everything that is in the bracket. That's why you have lambda square times y square. So in this case, we come to this point, 4 times everything that is in this bracket, 4 times lambda square times x square, you have what? 4 lambda square x square plus, yeah, this 6 now multiply everything that is in this bracket, lambda square x y. So we have 6 lambda square x y plus, in this case we have 8 multiply everything that is in this bracket, lambda square and y square. So we're going to have 8 lambda square y square. So if you check in this particular value we have here, we see that lambda is common in all of these things. We have lambda here, lambda square here, we have lambda square here, we have lambda square here. Because we have lambda square in all these terms, we factor what? Lambda square out of this term. So we have, it becomes lambda square bracket what will remain here now is what? 4x square. That's why I have 4x squared here. Then if you remove lambda square here, what remain what is what? 6xy plus, if you remove lambda square here, what remain here is what? 8y square. So our function lambda x comma lambda y become what? Lambda square bracket 4x square plus 6xy plus 8y square. And from this point, we know that 4x square plus 6xy plus 8y square was our first function of what? F, function of f xy. So we know that this f xy, this function was what? X 4x square plus 6xy plus y square plus 8y square. So we replace this term now here. So that's why I have lambda, this function of lambda x lambda y equals to lambda square. Instead of having 4x square plus 6xy plus 8y square, we put what? Function of what? X comma y. And because this f comma y now was equals to this particular function in this bracket, that's why I replace it here. So since we know that for us to get the degree is through this n that is on top of this lambda, this n here, and this our n here was symbolize the degree of the homogeneous function. So our degree here is what? 2. So our degree here is 2. The other way to find the degree of homogeneous function is to check the question. You see that this term now have power of what? Polynomial power of what? 2. And this particular function have power of 2 because this is a product term. When two terms being multiplied in indices, we add the power together. So here is raised to the power of 1 and here is raised to the power of 1. So 1 plus 1 it becomes 2. And here this particular term now is also raised to the power of 2. So it is a homogeneous function because all the terms are in the same power of what? 2. That is what homogeneous function is all about. So let's look at second example. Okay, let's look at this example 2. They say we should find the homogeneous function of this function of x comma y equals to x raised to the power of 3 minus 3xy raised to the power of what? 2. How are we going to find the homogeneous function of this? We know that from the process of finding homogeneous function, we are going to look at x. We replace x as what? Lambda x, and y as what? Lambda y, for us to cross check if we are going to have a homogeneous function of f lambda x comma lambda y equals to the function of x equals to what? The lambda n of x y. So we are going to cross check if we are going to have this particular lambda formulas or function. So in this case, we know that if we substitute lambda x, so from this place now we know that from this question we substitute what? Lambda x in place of what? X, and lambda y in place of y. So anywhere we see x, we substitute what? Lambda x, and anywhere we see y, we substitute what? Lambda y. So that's why we have, instead of f bracket x comma y, we have what? F bracket lambda x. This lambda x replaces this word x, and then this lambda y replaces this word y, equals to, here we have our x here. So instead of us to have x here, we put what? Lambda x raised to the power, which was 3, minus 3, this is our 3 here, times, instead of x here we put lambda x, times this y square. Instead of y we put what? Lambda y raised to the power 2, that is here. Then after that, we know that anything raised to power, the power will multiply everything in the bracket. So this power multiply this lambda become lambda raised to the power of 3. This power multiply this x become x to the power of 3 minus 3 times lambda x. Here we have lambda y square. So this square now we multiply this lambda become what? Lambda square. This square multiply this y become what? Y square. Then equals to what? The same lambda raised to the power of 3 times x to the power of 3 minus our 3 times these terms. You know that we have one lambda here times two lambda here. That's you have what? When two terms being multiplied, we add the power together. We have an invisible one here. So 1 plus 2 become lambda 3. Here x times y here become what? X y square, because this is y square. So x times this become what? Xy square. So we still have lambda. This lambda is power of 3 times x to the power of 3 minus this 3 now times everything that is in this bracket become what? 3 times lambda 3 times x times y square. And then since if we check here, we have something in common, which is lambda is power of 3. So we factor a out. We factor this lambda is power of 3 here out of this expression. So we are going to have lambda 3. When you remove lambda here, what remains here is what? When you remove lambda from this place now, what remains here is what? S cube minus, when you remove lambda in this place, what remains here is what? 3xy to the power of square. So from here now, we know that initially our f of xy was equal to x cube minus 3xy square. So that is why here now it's the same thing we are having here in this bracket, x cube minus 3xy square. So instead of leaving it like that, we substitute what? Let it be what? Let it be f of xy, because s of xy was equal to this value initially. So you just substitute it and put what? F bracket xy. So our lambda, our function of lambda x comma lambda y become what? Our lambda 3, our lambda is power of 3 times the function of x comma y, and this is in the form of a homogeneous function. And we always get our homogeneous, the degree of the homogeneous function from this lambda, which is our n. So our n now, which is our degree, become what? Is 3. So our lambda here become what? Degree of 3. That is our degree now is what? Degree of 3. This expression is of degree of 3, and this homogeneous function is degree of what? 3. So the other way to calculate the homogeneous function of this expression is to just to check if the power are the same. You know that here we have power of 3, and here 3xy square. You know that this particular function now have a power of 3 because this x have an invisible one. And when when we have product of a terms, we add the power together. So 1 plus 2 become what? 3, and this is power 3. All this function is of power 3, and this function is power 3. That make this homogeneous function, that make this expression as what? An homogeneous function, because they have the same what? Power. They have the same degree. So that is how to find the homogeneous function. Please, if you are not subscribed, subscribe to the YouTube channel so that I can go deep more in homogeneous equation. Thank you very much. Check next on homogeneous equation as we dive into it in full detail. Thank you very much. God bless you.